this is a review of the Edgenuity lesson, Negative Exponents. You don't have to listen to the whole video, so if you think you already have these properties, feel free to fast forward to when I do examples. But to start out here, I'm just going to kind of go over what they went over in the warm-up. And so the properties of exponents. If you have two separate bases that are being multiplied, you add the exponents. So I have x squared times x to the 4, so there's two x's there. So when that happens, you add the exponents. So 2 plus 4 is 6. When you have, like here, we only have one base. We just have that a there. When you have an exponent on an exponent like that, you multiply them. So here, if I have x squared to the 5th, you multiply them. 2 times 5 is 10, that's x to the 10th. So there's only one base, that one single x there. When you have an exponent on an exponent, multiply them. The second one, if you have a set of parentheses, essentially what you can do is just take your exponent, as long as this is multiplication, it doesn't work for adding or subtracting, you can distribute the m to both parts here. So if I wanted to do 4x squared, I can distribute the squared to the 4 and the x. So that's 4 squared times x squared, and then if you can ever evaluate the number, go ahead and do that. So 4 squared is 16. Negative exponents, I kind of have a simpler way to explain it than the video did. Basically, if you have a negative exponent, which you're not allowed to have when you are done with a problem, all you have to do is put a 1 on top and it changes it to a positive exponent. So if I have a 5 with a negative 2, I need that negative 2 exponent to become a positive. Just put a 1 on top. And then you get 1 over 5 squared, and then you can go ahead and evaluate the 5 squared part. That's just 25, so we end up with 1/25. So this next part says, what if the negative exponent is already in a fraction? So when we just had this 5 to the power of negative 2, it's super easy. Put a 1 on top, and now it's positive. Well, what if your negative exponent, like I said, is already in a fraction? When it's already in a fraction, if it's on the top and it's negative, you just move it to the bottom and it becomes positive. And vice versa, if it's negative on the bottom, you just move it to the top. The important thing though is you only move the thing that has the negative exponent. So like here, our y is to the power of negative 2. The z is fine. It has an imaginary exponent of a positive 1 right there. So we're going to leave that alone. The only thing we need to worry about is this y. It has the negative exponent. So what we can do is we can take that and just move it to the numerator. And when you switch its spot like that, it changes to the positive value. So it would be 4x squared. Scoot the y up. Now it's a positive 2 all over z is the final answer here. On the second one, we have 5x to the power of negative 2 over y. So here in the numerator, the only thing that has the negative exponent is the x. The 5 is separate because it's 5 times that value. Can't have negative exponent, so I'm going to move it to the bottom. So this becomes, now it's just a 5 on top. When we bring this down to the bottom, it's going to become a positive 2. So x squared times y there. I usually go in alphabetical order. That's why when I brought the x down, I put it in the front. But remember, you can multiply in any order, so it's fine to move them around. Anytime you have an exponent that's a 0, no matter what that thing is, it changes to 1. So 10 to the power of 0, it's 1. X to the power of 0 is 1. Negative 5 to the power of 0 is 1. Now, I will caution you on negatives. So here, we're taking this whole number, negative 5, and raising it to a power of 0, which is 1. If there are no parentheses, it's kind of tricky. What this is really saying is negative 1 times 5 to the power of 0. The 0 exponent is only on the 5. So what we end up with here is negative 1 times 1, which is negative 1. So the negative has to be in parentheses for it to end up being a positive 1. If there are no parentheses, your final answer stays negative. Last one, similar to this one here where we distributed the m to both parts inside the parentheses, you can also do that for division. It only works for multiplying. So essentially, if I do 4/5 squared, I can distribute the squared to the top and the bottom. So I get 4 squared over 5 squared, which is just 16/25. Okay, so a couple of more examples. What you can do is pause the video and see if you can do these, and then see if you get the right answer, or just work right along with me. So here we have an exponent on an exponent. It's 2 cubed to the 4th power. So when that happens, you multiply. And whenever you have numbers, you always want to evaluate. So 2 to the 12th power is 4,096. If I'm ever going too fast, you can always pause. On this one, we have 3/4 squared. So we can take that squared and distribute it to the numerator and the denominator. So 3 squared over 4 squared, which is 9/16. So I should circle my answers. On this one, we have 2 separate bases. So we have 5 to the power of -6 times 5 to the 4th power. So what we can do is we can put those together, but since there's 2 separate bases, 2 separate 5s there, that's when you add the exponents. So I'm going to go -6 plus 4, which is 5 power of -2. Can't have a negative exponent. So what do? Put a 1 on top. Now we can change it to a positive, and 5 squared is 25, so 1/25 there. Okay, now we're moving into ones without numbers. Okay, so similar to what we had here, we're going to distribute the squared to the top and bottom. So now we have r squared over t to the -5th squared. Exponent on an exponent means we multiply. So r squared over t to the -10th power, can't have a negative exponent, so it's already in a fraction, so all we have to do is just move it to the top. R squared t to the 10th power is that final answer. Okay, so the first thing we got to get rid of here is the parentheses. Remember that this is 7 times b to the -3rd power, so these are like 2 separate things. So we have to distribute the squared to both of them. So we end up with 7 squared times b to the -3rd power squared times b to the 5th power. So let's see. Oops, I left off a b. Sorry, there's another b there. Just in the original problem, I wanted to include another b. So go ahead and put that up there. So 7 squared is 49. Exponent on an exponent, so we're going to multiply that. Now this b here that we added on the end, it doesn't have a number there, but if there's ever a letter with no number, there's an imaginary 1. That's b to the 1st power. So now we have 3 separate bases, and when you have 3 separate bases, you add the exponents. So -6 plus 5 plus 1 is 0. So the only thing that has the 0 exponent on it is the b, because remember this is really 49 times b to the power of 0 is 1. So our final answer there is just 49. Okay, so on this one we have a lot of 2 separate x's and 2 separate y's. We kind of got a lot going on. You are not done with the problem until there's only 1 x in the whole problem and 1 y in the whole problem. So I'll start off here by just getting rid of the parentheses, distributing the squared. So x squared times y squared squared. When you have an exponent on an exponent, you multiply. So x squared y to the 4th power. Okay, again, we're not done. We still have 2 x's in there and 2 y's. So next I'm going to deal with my negative exponent here. Make that into a positive. I'm just going to move it to the numerator. So there's a couple of ways we can think about simplifying these x's here. What you can do when they're being divided is you just take away the smaller number from the bigger number. So what I mean by that is like, what's smaller, 2 or 3? Well, 2 is smaller. So what you can do is you can cancel this out, but you have to take it away from the bigger number. Essentially what's happening is you have 2 x's in the top and 3 in the bottom. So those on the top are going to take away 2 from the bottom. So just take the smaller number away from the bigger number. And at the same time, I'm going to put these together. 2 separate bases, so we add them. And then 3 minus 2 is 1. You can write the 1, but you don't have to. We'll go ahead and skip the last one. So if you have any questions on this, feel free to shoot me an email, or you can schedule a one-on-one Zoom.